Now let's consider the statistics of the random numbers, especially with the random numbers. How can we find the means and the variance of a random variables or random data sets? How can we find the mean and variance? And how can we find the movement and other useful properties in statistics? And finally, I will demonstrate how we can use Monte Carlo method to solve certain problems. The mean and the variance. The mathematical form of the mean, which is also called the mathematical expectation of a variable x or a sequence of x, which is defined like this. And the variance is defined like this. So if the probability density function p is given, we can easily find the analytical solution by taking integrals by the use of Matlab. For instance, we can use int function by integrals. And for a data set, if we have a certain x data set, then the mean value of it could simply be obtained like this. We can sum all the components and then divide it by the length of the vector. And the variance can be obtained easily also. And this is the mathematical details, how we can find the means and variances. And in Matlab, we can easily solve the problem by the use of mean function. If we have vector x, then you can find the mean of the vector. And we can use a VAR to find the variance of the sequence. And also we can find the standard deviation of the vector using the three simple commands. So in this way we can find analytically if P of x is given, or we can find the numerical method when the sequence of x is given. It should be noted that if x is not a vector, it is a matrix. If x is matrix, then we call mean x. What it does is to find the means on a column basis. That means to find the mean of the column vector as x1 and for the second column vector x2, like this. And the result of the mean function is then a vector instead of a value. So this is the differences. When x is a vector, find the mean of the vector. If it is a matrix, then you will find all the means of all the column vectors. So the question is, how can we find the mean of the whole matrix? What you need to do is to convert using a command like this. Convert a matrix into a vector. And then you can call a mean function. It can also be obtained by the nested use of mean function. However, there are limitations here. The limitation is that x must be a matrix. If it is a three-dimensional array or other kind of data format, this one cannot work. However, with the use of this one, x can be any data format. It can be a matrix or high-dimensional array. We can convert it first into a vector, and then we can use mean function to find the mean value of the vector. So these are the simple statistical analysis of the vector or matrix. And then we can also find the moment of random variables and not doing too much. too deep into this part. So there are definitions. The moments, there are definitions for row moment and central moment. If P is given, we can use Matlab command int to find the moments. If P is not given, instead we have vector x, then we can use Matlab command to calculate the row moment and the central moment. It could be very easy to find these properties. And there are other statistical analyses, such as covariance analysis, where we can find the covariance of two variables, which can also be done on theoretical analytical method or in numerical method. Now let's consider a useful numerical algorithm, which is called Monte Carlo method, which is heavily based on random numbers. Monte Carlo method is a method which uses statistical results to find certain quantities of random distribution. Here is an example. How can we find the value of pi? There are many different methods we can use to find the value of pi. And now I will demonstrate how can we find the value of pi approximately by the use of Monte Carlo method. Now let's consider a square here. The square is this square is with set length of 1. And we can generate easily random numbers within the square, which can be done quite easily using uniformly distributed method. So we can generate random numbers within this square, but the random numbers must be uniformly distributed. So we can actually generate points, which means x and y coordinates in the square. So what is the probability if a certain point falls into this area? The probability should be the area of this part divided by the area of the square, which is 1. So the probability should be something like pi over 4 probability. Now I generate 10,000 points randomly, and I will check how many points satisfy this kind of condition. If a certain point satisfies this condition, which means that this point is fall in this area rather than this area. So we can use a quantity here to find which of the x and y pairs satisfy this condition. That means fall into this area. And then we can count the number of points in this area as n1. So n1 divided by n, which is the total number of points, should equal to pi over 4. In other words, pi should be approximated by 4 times n1 divided by n. So this is a typical application of Monte Carlo method in the evaluation of certain values. For instance, here we find the